Alrighty. So, today, we are going to be continuing our Python course. So, throughout this course, we've already gone over a couple of the sections. And so today, we are going to be going over Logic 1. So, we're going to head over to CodingBat. And then make sure we're logged in. So we've done warm-up 1, warm-up 2, string 1, list 1. So now we're going to be moving on to logic 1. So as we can see, there's 9 questions here. So we're going to be going over the first couple of questions. And so here to take the first 2 questions is Pranav. So let's get that set up. And we're good.
Hello everybody. So today we're going to do cigar party. So first I'll give you some time to read the instructions because these logic ones have pretty long instructions. Okay. So it says when squirrels get together for a party, they like to have cigars. A squirrel party is successful when the number of cigars is between 40 and 60, that inclusive. So, unless it is the weekend, in which case there is no upper bound on the number of cigars, return true if the party with the given values is successful, or false otherwise. So, first, what do we do when it's not the weekend? See, what we do is we take off the upper bound. By upper bound, they mean the maximum number of cigars allowed. In this case, it would be 60 inclusive, so we should just take that off. For example, we would have the number of cigars are greater than or equal to 40. However, what should we do when it is the weekend? What we do is we keep the upper bound, which is 60. For example, we would have the number of cigars are greater than or equal to 40, but less than or equal to 60. One example they gave us here is the number of cigars right here is 30 and it is not the weekend. You see here where it says false. So we know that it is not the weekend, which means the number of cigars have to be in between 40 and 60 inclusive in order to result in true. But here the number of cigars is 30, which means that the answer is false. Okay, now in this solution, we're going to use traditional if-else statement, but there's one new thing. So here it has the elif statement. The elif statement is short for else if. So it allows us to check multiple expressions. If the condition for if is false, it checks the condition for the next elif block, and so on. So first, let's make the statement when it is weekend. We put if weekend is true. That means when it is the weekend, and cigars is greater than or equal to 40, we return true. And notice how it says and, so both conditions have to be true in order for it to return true. So then we need the second condition, and that's where the elif statement comes in. So we put elif is weekend, so when it is not the weekend, or when is weekend is false, and the number of cigars is less than 40, but less than or equal to 40, but greater than 6, my bad. Greater than or equal to 40, and less than or equal to 60. And then we return true. So and then notice here how it says or false otherwise. The otherwise is another keyword for else. So basically, whenever it says otherwise, you would put else, and then it says return false otherwise. That means all the other conditions which are not listed in the instructions. So that would mean else. So else return false. So when we click the go button, you get everything correct. Okay, now let's move on to the next one, which is date fashion. Okay, so this one's a long one. Give yourself some time to read it. Okay, so the directions are you and your date are trying to get a table at a restaurant. That is if you guys ever get one. Okay, sorry about that. Let's move on. So the parameter U is the stylishness of your clothes in the range 0 to 10. And the word date is the stylishness of your date's clothes. The result getting the table is encoded as an integer value, with 0 equal to no, 1 is maybe, and 2 is yes. If either of you is very stylish, 8 or more, then the result is 2, which is yes, with the exception that if either of you has a style of 2 or less, then the result is 0 or no. Otherwise, the result 1 is maybe. Basically, the word you means your stylishness level, and the word date means your date's stylishness level. So if your level or your date's level of stylishness is greater than 8, then the result is 2, which means yes, you get a table. So if one of your stylishness levels is less than or equal to 2, then the result is 0 or no, you can't get a table. Notice how I said or, which means if one of them, not both of them. So one example they give us here is when, right, when your the level is 5, but your date stylishness level is 2. So your level is 5 and your date stylishness level is 2. So basically, so here your date's level is less than or equal to 2. So you and your date can't get a table. So now let's get to the real solution. We have 3 results, which is 0, 1, or 2. So it would make more sense to go with the if, elif, and else type. So first let's start off when we do not get a table or return the value of 0. So we would go with if your level is less than or equal to 2, or your date's level is less than or equal to 2, return 0. So in right here, what I basically did was put a less than or equal to symbol right here. And then I put another one here. So if one of them is less than or equal to 2, it will return 0. And then let's get on with the next condition, which is the elif statement. So for the elif, we'll do the same, but we'll change the levels a little bit. So if your level is greater than or equal to 8, or your date's level is greater than or equal to 8, we will return 2. So right here, if that means your level, is greater than or equal to 8, or your date's level, or date, is greater than or equal to 8, you would return 2. And remember that 2 means yes, you get a table. So for the else statement, we will return 1. Why do we return 1? Well, it's important to notice again that in the directions they said otherwise, right here. Otherwise, the result is maybe or 1. So this means all the other conditions that were not listed in the instructions. So then we will use the else statement. And that's what we did here. Else is return 1. And once we're done with this, we click go, we get all green and noise.
Alright, let us switch back to this. Okay. So, this is squirrel play. So, this is the next question. Oops. So, I'll let you guys take a second, go over this question, go over the instructions, and after you're done reading, make sure you look at these cases, and then I'll go over them with you. So, let's go over the important things in this. So, the squirrels in Palo Alto spend most of the day playing. In particular, they play if the temperature is between 60 and 90. Okay, so let's remember those two numbers. And then, unless it is summer, then the upper limit is 100 instead of 90. So essentially, between 60 and 100. So, given an integer temperature and a boolean is summer, return true if the squirrels play, and false otherwise. So, we can go over these cases here, and we can see, so 70, and it is not summer, it's between 60 and 90, so we get a true. 95, and it is not summer, then it is a false, because they cannot play when it's above 90. Now it's 95, and it's true because it is summer, and since it's under 100, then they can play outside, so it's a true. So we gotta think about this. There's two main cases here, and that's going to be whether or not it is summer. And based on that, we can then decide the next thing, whether or not the temperature is fit, right? So no matter what, whether or not it is summer or not, we know that if it is 90 or below, then they can play outside. Well, between 60 and 90. That means that they can play outside. So let's think about it. Obviously, since this is going to be our classic if statement problem, most likely going to be using more than one if statement, so we need to think about how we're going to effectively write this. So if we were to take this question literally, right, we could go if is summer is equal to true, then we get these cases. And The alternative would be if it is not summer, so we just write an else statement. Now, once we get this, we can go if temperature is greater than or equal to 60 and the temperature is less than or equal to 90 or 100 because it is summer. Now that we know this, this is one of our true cases, so we can return true. And obviously with the other cases, since it is either under 60 or above 100, then we return false. And forgot the semicolon there. Alright, so we have this, and what we can do is we can just copy that, and we can paste that here. And so that means that the only parameter that was changed was the temperature is less than or equal to 90. Now this brings up something interesting. Well, if this temperature is going to be less than or equal to 90, right? Then what would happen? Basically, we copied and pasted this, and we know that the only special case is the difference between the 100 degree and the 90 degree. So if we're able to somehow combine these two statements, because essentially these two are practically just copies of each other. So I'll let you guys think about this for a second, how you might be able to combine these two statements together. Alright, so there's actually something very simple that we can do. So we see that, well, this is our classic return true and return false. So we can go ahead and delete this. And all we have to do is just return. Now there's one more step we can take. Since this is Python, we can actually just go ahead and write this. An inequality. So what this inequality tells us is that if this temperature is between 60 and 100 degrees inclusive, then it will return true. And if it is outside of this range, then it will return false. We can do the exact same thing with this. Oh, we have to remove the colon there. And we can do it to this. And all we have to do is change this to 90. And as we can see, we got all of the cases correct. Now, you can see that we were not able to simplify down those two copied if statements, even though they were super similar to each other. And that's something that you get to learn with more experience as a programmer. Because the more you program, the more you will begin to understand what you can do and what you cannot do. And many times, what you cannot do can be on a very almost close, it's a close proximity to what you can do. And oftentimes, in order to learn that you can't do something, you actually just have to go ahead and try it. And obviously, when you fail multiple times over and over again, you'll soon learn, oh, this is not possible. But many times, you'll fail because of different reasons. So it's important not to assume, but it's also important to try and make sure you truly understand what is going on. So, what I want you guys to do is I want you guys to understand the entire process that we went through in solving this problem. So, I'll let you guys think about that for a second. Now that you guys have thought of this, so essentially, I'm not going to say anything right now, but we're going to go over the next question, and I'm going to show you the pattern that we followed through every single one of these questions. So our next question is going to be caught speeding. So caught speeding. So I'll let you guys read over these directions. Again, these directions are a little long, and then we're going to go over these three cases. So I'll let you guys read over this for a little. Alright, so let's read over this. So you are driving a little too fast, and a police officer stops you. Write code to compute the result, encoded as an integer value. So we're no longer returning a true or false statement, or a Boolean value. So this is quite unique compared to the other questions we've done rather. So these are the cases that we have. 0 is equal to no ticket, 1 is equal to small ticket, and 2 is equal to big ticket. Now I'm sure we can all assume, okay, well 0 means that you're not speeding, 1 means that you're speeding, but you're not going too much overboard, and 2 means that you're going way, way too fast, right? So the speed limit is going to be 60, or if the speed is 60 or lower, the result is 0, which means you're not speeding. If the speed is between 61 and 80, then you're going to get a small ticket, and because the result is going to be 1. So this means that you're going a little bit too fast. And finally, it's going to be if the speed is 81 or more, the result is 2. And 2 means that you're going way too fast. But then there's an exception. Unless it is your birthday. On that day, your speed can be 5 higher in all cases. Right? So this is quite a unique problem. A, we're returning an integer. And B, there seems to be 3 cases as well, rather than our normal 2. But we can approach it the exact same. Since this is a logic problem, we're going to be using if statements. So let's go over these cases real quick. We have 60, a speed of 60, and it is not our birthday, because this is birthday parameter is false. And then we see, well, 60 is at 60 or less, so we don't get a ticket. Now we're going at 65, so this is between the 61 and 80 range. And since we're in the 61 to 80 range, and it is not our birthday, that means that we are going to be driving faster than we actually can. So we get a small ticket, because our result is then 1. Now again, we're driving at 65, except it's unique, because today's our birthday. And since today's our birthday, we can go 5 higher in all cases. So instead of this speed of small ticket being in the 61 to 80 range, it becomes 66 to 85. And since 65 is less than 66, we are no longer speeding, so we get no ticket. So let's keep in mind these cases as we program this. So let's go ahead and think, alright, so how do we start this off? So obviously, we're going to go with a simpler case, whether or not it is our birthday. So we're going to go ahead and write if is birthday, no capitals, and we have that case if it is our birthday, and we have the case if it is not our birthday. So when it is our birthday, all we have to do is just add 5 to all of the values. So if speed is less than 60 normally, then we just bring it up to if speed is less than or equal to 65. right? And that will lead us to a small ticket, or 0. And then we got to use the if-else, else if block. And this brings in our second case. If the speed is less than 60 or greater than 66 and less than 85. Now this is unique because again, we can bring in our inequality where if 66 is less than or equal to speed which is less than or equal to 85. And when we have this case, this means that we are going at just above the speed limit, or we get a small ticket. And finally, we don't need to write out this case because it assumes that we are driving at above our 85 limit, right? So we are 86 or higher. And when we are 86 or higher, we're going to be driving way too fast past the speed limit, and we receive a big ticket. So this finishes off our cases for when it is our birthday. So all we have to do is we have to copy this, we paste it here, and we just subtract each one of these inequalities by 5. So 65 becomes 60, 66 becomes 61, 85 becomes 80, and the else statement remains. So if we're to run this, we get all of these cases correct. So I'll let you guys look at this solution for a second, and we'll talk about how we can simplify this next. So, as we can see, when we go over this question, this is going to be our intuitive thinking. But we can always make some shortcuts, right? We can simplify things down. So, a couple of the things that we can do is, first of all, well, we can see that there's a uniform change in every single one of these statements. Now, in the last question, if we looked, there was not a uniform change, because in the lower level, it did not go from 60 down to 50. But rather, it went from 100 down to 90 in the upper limit, right? So, since we see that there's a uniform change, instead of going ahead and pasting this twice, writing some fancy if statements that encapsulates every single case, we can just go ahead and completely delete this. And when we delete this, that means that we have to re-indent everything over here, so we just press delete once. And now, if it is our birthday, in fact, all we have to do is just subtract 5 from our speed using this statement. Now, what did this statement actually do? Well, let's think about it. If it is our birthday, then your speed can be 5 higher in all cases. Or essentially, you can go 5 above every single one of the speed limits. And if we were to try and match the speed limits to our speeds, we have to bring the speed limits up 5, which is what we did with the if statements. But since we do this, we're essentially reversing the entire process, where we bring our speed down to the speed limit, or we bring our speed down by 5. And by doing this, all we have to do is just use our basic statements that we had in the second if statement. And when we run this, we can see that we get all of the cases correct. So, I'll let you guys look at this for a second, and then we can kind of look at the similarities between all of the questions that we've completed so far. So, now that you've gone over this problem, we can look at what are the similarities between all of the questions that we did. Well, this is a logic problem. And what a logic problem really means is that it's simply a problem that we might actually encounter in our lives. So, what does it mean by we encounter this in our lives? Well, logic is something that we use no matter what we're doing. It can be any small task, such as trying to efficiently get out of bed and be able to get to class on time. We take certain steps, we think about what we do, and we do it in a way where we waste as little time as we can. Obviously, this is excluding extremities, like whether or not we're super tired or something. But typically, that's how the normal human brain would run. Now, what these questions do is they test our logic. Now, obviously, when we go ahead and we look at these questions, it's quite obvious what we're supposed to do. If we were to be given any of these cases, it would be quite easy for us to just kind of work it out, even in our heads. We wouldn't need any paper, right? Because these questions are fairly simple. There's nothing much to them. And when we write it out, we can write it out exactly as we think. However, programming is slightly different from that. Programming is a way for us to kind of put down our thoughts and then further simplify it. And the reason why we can simplify it is because by putting down our thoughts, we can see our errors. And that's why when we make decisions in our lives, we always make the best one that we can think of on the spot. But there's almost always a way to improve that decision. And by writing it down, especially in programming, it is much, much easier to look at your errors and be able to identify them on paper rather than just trying to think them through. Which is why, when we solve these problems, it is perfectly okay when you write out kind of the first draft of the problem, or the first time you're trying to solve this problem, that you go ahead and you write down exactly what you think. Because writing down exactly what you think makes it so much easier for you to understand. And by making sure that you really understand your code, means that you're able to simplify it down to something that you can still understand, but is much more efficient. So, with that, we have 5 more questions in this. So, it would be good for you guys to obviously practice these 5 questions. And next class, we're probably going to be moving on to Logic 2. So, remember, Logic 2 is simply just an extension of Logic 1. As you can see, the instructions are still going to be quite long because it has to explain the scenario to us, right? We got to make sure that we get all of our kind of, we get our thinking together. And with that, if you guys have any questions, feel free to ask them right now. And if not, then see you guys next week. Alrighty, it looks like no one has any questions, so thank you everyone for watching, and see you guys next week.